In the spring of 1944, wheat fields from the Texas Panhandle to the Canadian prairies were facing a harvest crisis, not from weather, not from disease, but from the fact that the men who had always cut those fields were fighting a war on two fronts. The wheat did not know there was a war. It ripened on schedule, as it always had, moving northward with the season, Texas in late May, Kansas in June, Nebraska and South Dakota in July, the Canadian prairie by August. The USDA Bureau of Agricultural Economics documented the labor shortage in its wartime reports with stark numbers. By 1944, an estimated 6 million farm workers had left agriculture for military service or war industry jobs. The Great Plains states had lost between 25 and 40% of their experienced harvest labor. Unharvested wheat does not wait. Once a wheat crop reaches peak ripeness, the window before the heads begin to shatter, dropping grain onto the ground before it can be collected, is typically 7 to 14 days, depending on weather. Rain, wind, or a return of summer heat can collapse that window further. In the spring of 1944, James S. Duncan, executive vice president of Massey-Harris Company, approached the War Production Board with a proposal that was, on its surface, counterintuitive. Give us priority steel to build more farm equipment during a war that was consuming steel at an unprecedented rate. Duncan's argument was documented in the War Production Board correspondence. 500 self-propelled combines, each operated by a single person, could harvest the grain that would otherwise require labor that simply did not exist. Without the machines, the wheat would be lost. And lost wheat in 1944 was a military supply problem, not just an agricultural one. The War Production Board approved the allocation. Massey-Harris was authorized to build 500 additional Model 21 self-propelled combines using priority steel on one documented condition: the machines had to be used in an organized, coordinated harvest operation, not scattered across individual farm sales. Before we follow those 500 machines north through the wheat belt, we need to understand why the self-propelled design was the machine that made this possible and what it replaced. By the early 1940s, the standard grain harvesting operation on the Great Plains used a tractor-drawn combine, a large machine pulled by a tractor, with its own internal engine powering the threshing, separating, and cleaning mechanisms. A standard tractor-drawn combine operation required a minimum of 2 people to operate effectively, one driving the tractor, one monitoring the combine's threshing and separation systems from a separate platform. Support crew for grain cart operations, mechanical adjustments, and refueling could bring the total team to 5 or more on a full-scale operation. The tractor-drawn design also had a visibility problem that experienced operators knew well. The tractor driver, seated ahead of and above the combine header, had a limited view of exactly where the cutting platform was entering the standing crop. In irregular fields, around obstacles, or at the edges of a pass, this limited visibility resulted in missed grain and occasional header damage. The third limitation was maneuverability. A tractor and an attached combine form a long, articulated train that is difficult to turn precisely at the end of a pass. On small or irregular fields, the turning radius consumed significant time and sometimes required backing maneuvers that risked damage to both machines. Massey-Harris engineers had been working on the self-propelled combine concept since the mid-1930s. The fundamental idea was straightforward: combine the propulsion and harvesting systems into a single, unified machine, eliminating the tractor entirely and placing a single operator in an elevated, forward-facing position with a direct sightline to the cutting header. The Massey-Harris Model 21 self-propelled combine entered commercial production in 1938. Its design placed the operator in an elevated cab directly behind the cutting header, with an unobstructed forward view of exactly where the header was entering the standing crop. The engine driving both the propulsion and the harvesting mechanisms was a Chrysler 6-cylinder gasoline engine, producing approximately 101 horsepower, enough to power the machine through standing wheat at a working speed of 3 to 5 miles per hour, while simultaneously running the full threshing and separating system. The cutting header on the Model 21 was 12 feet wide, the width of crop it could cut in a single pass. At a working speed of 4 miles per hour, a 12-foot header covered roughly 4.8 acres per hour of net cutting time. Compare that to the tractor-drawn combine it replaced. Similar header widths, similar threshing capacity, but requiring 2 operators rather than 1. The self-propelled design did not increase cutting speed. It halved the labor required to achieve the same output. In a year when experienced harvest labor was the scarcest agricultural resource on the continent, having the operator requirement was not a marginal improvement. It was the difference between a harvest and a loss. The Model 21 also incorporated a grain tank rather than the grain bags used on many earlier machines, holding harvested grain on board until the tank was full, then unloading into a grain wagon or truck via an auger without stopping the harvesting operation. A single operator could keep the machine cutting continuously, with periodic stops for unloading, fuel, and mechanical checks. The turning radius of a self-propelled machine, a single integrated vehicle, was significantly tighter than the tractor plus combine train. At the end of each pass, the operator could complete the turn and re-enter the standing crop in a fraction of the time and distance required by the tractor-drawn configuration. The Smithsonian National Museum of American History holds a Massey-Harris self-propelled combine in its agricultural machinery collection, preserved as a historically significant example of the machine that changed the labor structure of American grain harvesting. Now back to 1944 and the 500 machines that the War Production Board had authorized, moving south to north across the American wheat belt in the most documented harvest operation in the history of American agriculture. The operational plan was documented in both Massey-Harris Company records and the Farm Implement News coverage of the 1944 harvest season. The 500 combines were distributed to a network of operators, most of them custom harvesters, who owned or leased the machines and contracted their services to farms along the route. The harvest route followed the natural northward progression of wheat ripening, a seasonal wave that moves at approximately 15 to 20 miles per day as summer advances. A combine operator who finished in the Texas Panhandle in late May could follow the ripening front into Oklahoma in early June, Kansas in mid-June, Nebraska and South Dakota in July, and reach the Canadian prairie by late July or August. This route, Texas to Canada, following the ripening front, is approximately 2,000 miles of continuous wheat country. A combine operator running the full route from late May through August could harvest wheat across 7 states and 2 countries in a single season, moving north with the crop. The operational challenge was not just harvesting, it was logistics. Moving a 12,000-pound combine from a finished field in Kansas to the next contract in Nebraska required a lowboy trailer, a tow vehicle, and knowledge of road weight restrictions, bridge clearances, and fuel availability along the route. Massey-Harris provided route coordination support for the Harvest Brigade operators, documented in company records as a network of regional contacts who could direct operators to farms with red wheat, supply parts and mechanical support along the route, and coordinate with grain elevators on receiving capacity. The grain elevators themselves were a critical part of the operation. A combine operator arriving at a farm with a full grain tank needed to know the nearest elevator had receiving capacity before beginning harvest. Grain backed up at a full elevator could halt an entire field operation. The 1944 season results were documented by both Massey-Harris and the USDA. The 500 Harvest Brigade combines harvested an estimated 1 million acres of wheat during the 1944 season, grain that, by USDA wartime assessments, would largely have been lost without the mechanized operation. 1 million acres. At the Model 21's documented working rate of approximately 4.8 acres per hour, 500 combines operating 10 hours per day over a 90-day season could theoretically harvest 216 million acres, far more than was required. The real constraint was always logistics, moving the machines, finding the contracts, coordinating the route. Farm Implement News, in its 1944 season coverage, archived at the University of Wisconsin, described the Harvest Brigade as the most organized agricultural operation in American peacetime memory, a phrase that captured both its scale and its military-style coordination. The Harvest Brigade's significance extended well beyond the 1944 season. It proved at continental scale that a single operator in a self-propelled combine could do the work of a multi-person tractor-drawn team, and it demonstrated that those operators could be organized into a coordinated, mobile harvesting force that followed the crop rather than waiting for the crop to come to them. That demonstration created an entirely new industry in American agriculture. Professional custom harvesting operators who owned their own equipment and contracted their harvesting services across multiple states and multiple farms in a single season. The custom harvesting industry that the Harvest Brigade helped establish in 1944 still exists today. Every summer, professional custom harvesters move north, through the wheat belt from Texas to Montana, following the same seasonal ripening wave that 500 Massey-Harris combines traced in 1944. The self-propelled combine design itself became the industry standard within a decade of the Harvest Brigade. John Deere introduced its first self-propelled combine in 1947. International Harvester followed in 1942 with the Model 55 SP. By 1955, tractor-drawn combines had become the minority on large-scale grain operations across North America. By 1960, USDA Census of Agriculture data shows that self-propelled combines had displaced tractor-drawn designs on over 80% of large-scale grain farms in the United States, a transition that took less than 20 years from the Massey-Harris Model 21's commercial introduction in 1938. James S. Duncan, the Massey-Harris executive who negotiated the War Production Board allocation, later described the Harvest Brigade in company records as the moment when the self-propelled combine proved itself not just as a machine, but as a system. That distinction between a machine and a system is worth dwelling on. The Model 21 was a capable machine in 1938, but it became a transformative technology in 1944, not because the machine improved, but because someone organized 500 of them into a coordinated operation and proved at full scale what the engineering had only suggested on individual farms. This pattern, a proven machine technology waiting for someone to organize it at scale, appears repeatedly in agricultural equipment history. The mechanical reaper was commercially available for years before McCormick built the factory and dealer network that made it ubiquitous. The steel plow worked for individual farms for a decade before Deere's mulling operation made it available at the scale the Midwest required. The Harvest Brigade was the organizational breakthrough that the self-propelled combine needed, and Massey-Harris's willingness to commit to that organizational challenge, not just the engineering, is what the historical record shows, made the difference. Now, what does the documented record of the Model 21 and the Harvest Brigade mean for anyone interested in the history of vintage equipment, or for anyone who encounters one of these machines today? The Massey-Harris Model 21 SP is one of the most historically significant combines in the vintage equipment world, and one of the more challenging to find in restorable condition, precisely because the Harvest Brigade put its machines to work harder and across more miles per season than almost any farm combine of the era. The machines are identifiable by the distinctive red and straw yellow Massey-Harris color scheme, the elevated operator platform positioned directly behind and above the header, and the characteristic profile of the Chrysler six-cylinder engine cover on the right side of the machine. The Chrysler engine used in the Model 21 is the most commonly cited challenge in restoration. Parts availability is limited, and finding a rebuild quality block requires specialist sourcing. The good news is that the threshing and separation mechanisms, the internal grain processing components, used more standardized parts that remain available through a wider network of vintage combined parts suppliers. For anyone who wants to see a preserved example, the Smithsonian's Agricultural Machinery Collection remains the definitive reference. Regional agricultural museums, particularly those in Kansas, Nebraska, and the Canadian Prairie provinces, also hold documented examples of 1940s-era Massey-Harris equipment, including some with documented Harvest Brigade provenance. The engineering lessons of the Model 21 that are still relevant to anyone thinking about harvesting equipment, vintage or modern, come down to three documented principles. The first principle, operator sightline to the work surface, determines precision more than any other single design variable. The reason the self-propelled combine outperformed the tractor-drawn configuration in field edge and obstacle work was not power or capacity. It was that the operator could see exactly where the header was entering the crop at every moment. This principle appears in every significant harvesting equipment improvement of the 20th century. The forward cab design of modern combines, the rooftop camera systems of current precision agriculture, the elevated operator platforms of modern grain carts, all trace back to the same fundamental insight: operators who can see what their machines are doing make fewer errors and lose less crop. The second principle, labor efficiency and machine capability, are not the same variable. The Model 21 was not dramatically more capable than the tractor-drawn combine it replaced. Similar header widths, similar threshing capacity. What it delivered was the same capability with half the labor. In 1944, that difference was decisive. In any labor-constrained environment, it remains decisive. The third principle, a machine proven at the farm level, requires organizational proof at the system level. The Model 21 was a good machine from 1938. It became an industry-transforming machine in 1944 when the Harvest Brigade proved it could operate as a coordinated system across a continent. The engineering and the organization together created the transformation that the engineering alone could not. That's the documented story of the 1944 Harvest Brigade, recorded in USDA wartime reports, Massey-Harris Company archives, and the trade press of the era, and still visible today in the custom harvesting industry that it helped establish 80 years ago. 500 machines, 1 million acres, a season that lasted from Texas in May to Canada in August, and an industry, custom harvesting, that still follows the same route today, every summer, exactly as it did in 1944. If this kind of documented equipment history is what you come here for, subscribe to The Quiet Farmer. We cover the machines that built American farming, the engineering, the history, and the record behind them. In the comments, tell us, does your family have any history with custom harvesting or with Massey-Harris machines from this era? If you have a Model 21 or have worked on one, we'd especially like to hear from you. The lesson here isn't nostalgia. It's that the machines which changed how an entire continent fed itself were built by people who understood that engineering and organization together accomplish what neither one can manage alone. We'll see you in the next one.